Okay, so section 2.2, last section before fall break. This will be due October 11th. Solving linear equations, pretty simple. First of all, how do you know it's a fancy word, linear equation. How do we know we have a linear equation? What does that mean?
The slope is constant.
Yeah, so we'll call this example one. We're just gonna say solve for x. So when we look at this problem here, what about it tells me that it's linear? So you say that it's slope, but there's a little bit more to it. What do you know about the variable x? For it to be linear, x has to be what? To the power 1. That's right. Can't have any square roots. You can't have any x squares. So nonlinear would be equations that have square root of x, x squared, x cubed, absolute value of x, all of those. So it has to just have x to the first power, and not in the denominator either. Okay. So, all right. All right. So first problem. So now let's go through this. I know it's the most basic, but these will get a little bit more complicated. What are our steps for solving for x? What do you do? What's that?
You want to get it by itself.
Yeah, so,
you would add 3.
right, so what basically, what we're always gonna do is the inverse. The inverse of subtracting is adding. Then we're gonna do the inverse of multiplying, which is dividing, and so on. And so, yeah, so solve for x. My hint is always gonna get x by itself, right? How do we do that? So you're right, the first step is add 3. We have negative 9x is 27. And then finish that one from there. And then we'll do a problem where we have multiple x's. Okay. So really, this problem is about a 2-step problem to isolate x. You add 3, you divide by negative 9, then what answer did you get? Yep, x is negative 3, very good. Now, so now you can see I bumped it up a level to when we go to part B. It's still considered linear, it's just here you have, if you combine these two linear functions, you get one linear function. You have a linear function on the right. So now what am I going to do if I have a multiple x's like this? So I have like a 5 minus x, I got the x minus x. So how do I get x by itself if I have 3 separate x's? Well, let me ask you this, if I had an x, let's say I had an x plus a 3x minus an 8x, can you add them all up? So if you add these all up, what would this add up to? Just add the 3. Negative 4x. There's the answer to your question. If you have more than one x, added and subtracted, just combine them like it's like terms, and you end up with 1x. So that's what we're going to do on this. When we have all these x's like this, so the first thing I'm going to do on a problem like this, where it's a little bit more difficult, is I'm going to expand. What it means is I'm going to distribute my negatives, and then I'm going to get all x's on one side, and that will help me to solve. All right, so try those 2 hints and see if that helps. So expand it, which means distribute your negatives, and then get all your x's on one side. So, let's look at this. Let's go step by step. So, my first hint was to do what? Expand. Expand means get rid of these parentheses, distribute with any distribution we can do. So if I distribute the negative here, it becomes what?
Negative 5 plus X.
And then here, if we distribute the negative, it becomes what?
Negative X.
All right. And then we have equals, and then we got 7x minus 2. Now, what can you go ahead and do with these two x's? They cancel, okay? All right? And then now, you see how it kind of is starting to simplify. So now we have negative 5 and 2, which adds up to negative 3. We have 7x minus 2. Now we said get all the x's on one side, so I would just leave them on the right for now. So I'm going to leave x on the right and try to move everything else over. So I'll add 2. When I add 2, I get negative 1 and 7x. And then what's my last step here to solve? Divide by 7.
Yeah.
7 is in there. You have x is negative 1, 7. There's your solution. All right. Let's do one more. And then I want to talk about the meaning of our answer, and then we'll go from there. All right. Let's call this one part C here. This one here. So let's say we have 3x minus 4 equal to negative 2x plus 1. So again, it's all solved for x. We're going to solve for x. I know the Spanish word for x called loco. You know my Spanish. How cool is my concert shirt, man?
I'm sorry.
You guys know? You know who Dave Matthews Band is? I love these. I get they're the stretchy soft ones. I love the stretchy soft. Okay. So let's go through and solve this thing and see look at our answer. I picked one on purpose because I want to kind of talk about it. So it's a linear equation because there's no square roots, x squared. You're going to see, if I just cover the right-hand side up, do you guys agree that the left is the equation of a line? Yes. If I cover the left-hand side up, do you agree that the right-hand side is the equation of a line? Yeah, okay. So now, if we go and solve, I like to eliminate negatives when I can, so I would have added 2x over. So I have 5x minus 4 is 1, and then my brain is working too fast. And I would have added 4 over. So I have 5x equals 5, then divide by 5, so x is 1, okay? But my question is, I did this one on purpose because I want us to visualize what that means. So this means, yeah, this is, if I plug this in, it should be true, right? That's what it means. So if I plug a 1 in, I get negative 1 on the left, I get negative 1 on the right, check mark. It's true. But what does that mean? So there's one meaning is, it is the value that, I call it Snickers, that satisfies the equation. All right? So it means that if you plug it in, your equation should be equal. There's another meaning, a graphical meaning. Can anybody tell me what that means? Yes? Yes, that's exactly right. So what Allison said, she said, look, if you graph these two lines, it's where they intersect. Okay? So, because I wanted to show you that, so I don't have a great graph paper up here, but we can make do. All right, let's see. So 3x minus 4. So 1, 2, 3, 4, up 3, 1, 2, 3 over 1. There's that line. And then negative 2x plus 1 down to over 1. Oh, there it goes. So if I graph the two lines with their y-intercept and their slopes, there's one line. There's the other line. Notice they both cross at what x? At x equals 1. And let's see the picture right here. So this point of intersection 1, negative 1, that's what we found. We found at least the x. Then you plug it into either one and you get the same one. But I just want to show you that so you can visually see that, what it means. So if we think of it as graphs, there's three scenarios that can happen with lines. One scenario is they cross. That's one scenario. All right. There's this. Part B. Solve this one. Solve for x. Let's see what happens. Remember what we said, expand first and get all the x's to one side and see what happens. Try to get x by itself. Okay, so what happens? The x's cancel. So if we distribute it to, we get 8x plus 16 equals 8x minus 7. So remember, get your x's to one side, get everything else to the other. So if I subtract 8x, I get 0. Plus 16 is negative 7. So I have 16 equals negative 7. Is that true? Can 16 equal to negative 7? No. So this is called a contradiction. Anytime this happens, this is called a contradiction, which means that there's no solution. But graphically, does anybody know what that means happened? What happened with the two lines? Yeah, the parallel. Look, if I look right here, see both of those have the same slope, but different y-intercepts. They're parallel lines. That's what that means. Okay? All right, so a contradiction is any time that the equation is not what? What would you say? Not true. It's false, right? 16 can't equal to negative 7, right? It's a false equation. That's why we call it a contradiction. So if your x's cancel, that's one scenario. The other thing that could have happened is this. So let's just work through this one together. So when we go to start solving, I distributed 2, I have 8x plus 16 equals 8x plus 16. If I subtract my 8x from both sides, I get 16 equals 16. But my x's are gone. So anytime that you get the same thing equal on both sides, this is called an identity. Okay? Identity. But does anybody know why we got that? What the second line, I think, is where it tells you. Do you see what's happening on the second line? The second part of this. What do you see? Hank, you wanted to answer the last question, now you answer this one. What happens on the second step of this? Overthinking it. Look at the second step on this problem, and it should be pretty obvious as to what's going on. So what does each one individually stand for? This on the left is a what? We're talking graphically. A line. This on the right is a line. What do you notice? They're the same. They're the same line. So if you basically have a line on top of a line like this, here and here, it's the same line. So they're always true. So how will you know that? Well, you'll get something that's always true. 16 is always equal to 16. Nothing I can do. Okay? So it's called an identity. What does this mean? It's the same line. Okay? All right. So does everybody understand when we get a contradiction and when we get an identity? Other than that, when you start working the problem and you get an answer, that's just called a conditional. Okay, conditional. So we'll write this. Sorry, my handwriting is sloppy. So conditional is when you just get a solution. X is 2, X is 3, what we've been getting. Okay. So this is an identity. That's a contradiction. Had I solved and got like X is equal to 1, like on the previous problem, that's called a conditional equation. Okay. It meets the conditions. You get a solution. So that's why in your notes you kind of want to put that. So if you get something that's always equal, no x's, identity. No x's, but you get something that contradicts itself, contradiction. All right. Does that help you a little bit there with that? Okay. Just to save that terminology, okay? And then the last one is, now let's up the level of difficulty on some of these and look at how we would solve them. So,
trying to find something that
I lost my example numbers. What am I ready for? Can you guys see? Example, maybe example 2 by now? Example 2. Solve for x. So here we go. We've got all right. So now I've increased the difficulty. It's still a linear equation, and at the end, we're gonna label this. Is it a contradiction? Is it an identity? Or is it conditional? Conditional means you got a solution. X equals something. Okay, you get a solution. So let's see which of those two. So why is this one so much more difficult? What's more difficult about it? Fractions. All right. What are the two numbers that you see that you wish weren't there?
5 and 30.
All right, we're going to make them disappear. So that's how we're going to work this problem. The way we work this, when you have fractions like this, the first thing is get rid of the fractions. So the first thing is we're going to eliminate the fractions and then we'll solve from there. So the question is, how do I eliminate the fractions? Well, what are the rules of equations? There's certain rules that you have that you can do. Can you add the same number to both sides of an equation? Yes, that's what we've been doing to solve, adding like 4 to both sides or adding 3. Can you subtract the same number from both sides of the equation? Yes. Can you multiply the same number to both sides of an equation? Like if I had 1/2 x equals to 3, I could multiply both sides by 2 and get x is 6. Here's a situation where I want to multiply. If I had 5x equals to 10, I would also, on this part, I would divide both sides by 5 and get x is 2. So you can add, you can subtract, you can multiply, divide. The only thing I can't multiply or divide by is what number? What's the one number you can't multiply or divide by?
1.
0. 1 doesn't change anything, but if I multiply by 0, it destroys my equation. I don't have one. So you can't multiply or divide by 0. This is typically what you do at the last step. However, you can multiply and divide whenever you want, as long as you do it to everything and you do it to both sides. Just the rules of equations. So when I look at the 5, I want to get rid of the 5. Here's how I can get rid of the 5. If I multiply each part by 5, these 5s will cancel. Okay? Which is one, at least I get rid of one thing. But I'm going to multiply, so I'm going to look, I'm going to see what my denominators are. So I'm going to multiply everything by 5 first. Okay? All right, so do that. So now, on the first one, don't multiply the top by 5. I'm doing this on purpose, so these two 5s do what? Cancel. Now here you got to do 5 times 2, and here you got to multiply the top by 5. Go ahead and get that done. So the first thing I did was I multiplied by 5 because I saw 5 was one of the denominators. So I'm just going to kind of put a box everywhere I multiplied by 5. So there's 3 parts to this. I multiplied all 3 parts by 5. Okay? So the 5's cancel here, and I'm left with 3x minus 1. Minus 5 times 2 is minus 10 equals, now on this one, I have to multiply the 5 to the whole top, and I get 10 minus 5x over 3. All right? Okay. Hey, can you put your phone up for me? Guys, no, your phone doesn't need to be out when I'm up here teaching, okay? All right. So there's that. Now I'm going to change this over here to probably 3x minus what? If it's minus 1 minus 10, I can make it 3x minus what? 11. Okay. All right. However, I'm still not happy because why? I still have another fraction. So now I multiplied everything by 5 to get rid of this 5. So now I need to multiply everything by what? 3. Now that means the 3x, the 11, and then this thing get multiplied by 3. So I'll do that here. So you could put parentheses on the left if you want. 3 times 3x minus 11 equals 3 times 10 minus 5x over 3. Because I want to show that the whole left is multiplied by 3 and the whole right gets multiplied by 3. But I'm not really going to multiply on the right, am I? What am I really going to do on the right? That's exactly right. I'm going to get rid of the 3. And then you can solve. So distribute your 3 on the left, and then cancel your 3 on the right, and then it's easy to solve the problem. So here on the left, if I distribute my 3 minus, multiply both of them by 3, so 9x, yep, equals, on the right, my 3's cancel, this stays 10 minus 5x, and then you can finish the problem. So everybody see how one at a time I eliminate the denominator. There is a way to kill 2 birds with 1 stone, but I prefer doing it this method. And you can just rearrange, and then you're going to answer, is it a contradiction, is it an identity, or is it a conditional? not gonna be a pretty answer, just reduce your fraction as much as you can. Remember, don't get in the habit of decimals, in course compass, they want fractions. Okay, so are you gonna move the 9x over, or are you gonna move the 5x over? Which one did you guys do? Yeah, I would add the 5x to get rid of the negative. So that gives me 14x minus 33 is 10. Then I'll add 33. So I get 14x is 43. Well, not much I can do with 43, is there? So just divide by 14 and you're done. X equals 43 14ths. So is that a contradiction, an identity, or a conditional? Conditional. You got a solution. Okay? All right. So any questions on how I got rid of the fractions there? Okay. Last one. This is going to seem pretty silly. The last type of problem you're going to get. Let's say you have one like this. I'll just say this here. Just call this example 3. Solve for b. So you have 2a plus 3b equals to 11, something like that. Okay? So again, whatever it says solve for, you're going to isolate. Now the only problem is I can't get rid of the a. The a is just going to have to be part of the answer. So on this type of problem, just move everything that you can, do the steps to get b by itself, and then you'll see that your b will have a in the answer. It's okay. So the last problem, we're not really going to get a single answer. We're just going to solve for b by getting it by itself. Okay? So what's the first thing I'm going to do? Give me the first step you would do to start to get b by itself. Minus 2a, there you go. And then just really a two-step problem and you're done. So you're going to have a's in the answer. All right. So I subtract 2a, like Sticky said, so 3b equals 11 minus 2a. Now there's only one more step. Since this, this is 3 times, you divide by 3, and so you get b equals 11 minus 2a over 3. So you kind of get a formula for b. Give us your a's, we'll plug in a and we'll get b. This is the last type of problem that you'll work in this section. Okay, I'm going to stop the video here so I don't have to upload so much. All right, that's it for fall break.